Welcome to the video for Geometry 3.5. Equations of parallel and perpendicular lines, I think it is. I forget the name of it. Forgot to look it up. But pages 88 to 90, I believe here. This is pretty much a straight review of algebra. And we have also done some of this earlier this semester, so this should be an opportunity to continue to improve and take advantage of that. First thing, we have directed line segment. RC is a segment that represents moving from point R to C. So basically, if I have this is R, this is C. Directed means we're starting here and we're going, it's not a ray, but we're going from here towards that direction, okay? And we're going to learn to find portions of that. Slope of parallel lines. Now, if you have troubles reading these highlightings, please let me know. I've been checking this is printing better than it used to. I'm going to leave some of these on here. So I was experimenting with a little bit today. Slopes of parallel lines in a coordinate plane, which is pretty much everything we do. Two non-vertical lines are parallel if and only if they have the same slope. So if they're parallel, remember, if and only if means forwards and backwards. So if they're parallel lines, they have the same slope. If they have the same slope, then they're parallel. It also mentions here any two vertical lines are parallel. Now, please note, you must have different y-intercepts. It's not just that the slopes are the same, because you could have overlapping lines if you don't have if they have the same y-intercept. Reduce slope values too. I got our little formula for slope here, and I'm sorry, this doesn't show the highlights like it used to with my pen, and I can't figure out how to start that again. So rise over run, delta y over delta x means change in y over change in x. This is related to this term over here, y2 minus y1 over x2 minus x1. Most of you know this. The popular term for slope nowadays is called rate of change. That's related to this change in y over change in x. So if you hear somebody asking you for rate of change, they're just asking you for the slope. Perpendicular lines, this is a little bit more challenging. In a coordinate plane, two vertical lines are perpendicular if and only if the product of their slopes is -1. Now, that's not the way usually people think about it. I also mentioned down here, horizontal lines are perpendicular to vertical lines. So m1 times m2 equals -1. Why does that work? Most of us think of this as opposite and reciprocal. So if I have a slope of 3 over 2, and I do the opposite, that's -3 over 2, that's my opposite. And then if I do the reciprocal of that, that's -2 over 3. And that would be it. But if I check these, so this would be my m1, that would be my m2, the perpendicular. If you check that, 3 over 2 times -2 over 3, I mean, you could just multiply this out to -6 over, whoops, not negative there, 6, which is -1. Or you could reduce to 1s, you could reduce to 1 and -1, and you can still see that coming out to -1. But that's a little bit more tough. Why does this work? Opposites always multiply to a negative. Reciprocals always multiply to 1. So when I do opposite and reciprocal, I'm going to get something that multiplies to a negative and something that multiplies to a negative. So together that gives me my -1. Just so you know why that works. That's really it for the notes here. There's not a lot to do here. We've done this before. You should be working with writing an equation. So remember, pause this before I do the problems. Try them on your own. And if I didn't have that bigger before, I apologize. I should have that bigger. So this is our directed line slope. So I give you a little hint here. Don't reduce your slope. So I'm going to go x2, y2, x1, y1. And that's going to give me, my slope is 7 minus 1 over -2 minus -4. That's going to give me, that goes to plus a positive there. That's going to give me 6 over 2. Now, normally I would reduce that. I'm not going to reduce it right now. Okay, now for this slope, or for this here, a to b. I got to change this to a fraction. This is going to go into a over a plus b. So this is going to give me 3 over 3 plus 1, which is 3 over 4. Okay, so now, remember, this is change in y over change in x. You want to remember y's are on top, x's are on the bottom. So now I'm going to do 6 times 3/4. In your calculator, you can just do 6 times 3 divided by 4, and that will work in your calculator. You can do other things too. 6 times 0.75, that'll work too. And that gives me 4.5. Okay, so I'm going to take here, I'm going from A to B. So for my point P, I'm going to start with my point A. It's going to be -2 plus that 4.5. And that's one of my points. I'm going to do the same thing for the 2 here. I'm going to do 2 times 3/4. That's going to give me 1.5. 2 times 3 divided by 4, 1.5. So I'm starting at 7. I just caught a mistake. I am doing this in the wrong spot here. So I'm going from A to B. Okay, I do need to graph this one. This is very different than the ones in the book. Sorry to use up the space over here. I didn't really plan for this. So I got -2, 7. That would be right about there. A is -2, 7. B is -4, 1. So I'm going from here to here. And I'm going to have to subtract for these values. So I'm just catching that right now. So for my x, I'm going to have to do 7 minus 4.5. Going from A to B, because I've got to go down, and then I got to go left to get that way. So that's going to be a minus going down. And over here, I should have, where's A? -2 minus 1.5, because again, I got to go to the left. That's going to give me P is -3.5, -2.5. There's my answer. It works out. You don't get these, don't worry about that. These are honors level problems. I wanted to try it. I haven't done these much before. Determine which lines. So on this one right here, you're going to do similar on number 4. On this one, so you got to give me the slope of the line. So remember, it's not just using your eyes here. I need to see the slopes. So I've got S, R, T, line P, and line Q. So you can do this a couple of ways. I can do the slope of line P. So that's this line right here. I'm going to go from this point to this point. I got a rise of 3. I've got a run of 3. That gives me a slope of 1. So you can count them out. Or, whoops, MQ. So I got this one. Or I could use the points here. I could use this point, and I could use my formula. Those points are on the lines there. This is going to be x2, y2. This is x1, y1. So I got negative 4 minus negative 1 over 0 minus 3. Okay, that goes to plus a positive. That gives me negative 3 over negative 3, which again is equal to 1. Geez, I can tell I got two parallel lines here because their slope came out the same. So one of our answers here is going to be P is parallel to Q. Now I got to do the same for all these other lines here. Okay, now since this is a slope of 1 over 1, if I do the opposite, this changes to negative 1 over 1. If I flip it over, that's 1 over negative 1, which is still negative 1. So this is my perpendicular slope that I'm looking for those lines. And I need to find that. If it has a slope of negative 1, then it's perpendicular to P and Q. So, but make sure you just tell me the answers. I don't see the slopes shown. I don't give you any credit for the problem. This is just finding your slopes. Again, you can do x1, y1, x2, y2, x2, y2, x1, y1, any way you want it. Either way is going to work. Find the slopes, compare them just like you did on number 3. Notice I got scrambled answers here. Write an equation. I don't know why they don't put the graphs on these. So put in your axes. I put some values on there. So I'm going to graph the first line. Negative 1 is my y-intercept. Up 2 over 3. Up 2 over 3. That's the same as positive 2, positive 3. Same as negative 2, negative 3. Negative 2, negative 3. There's my first line right there. Now, let's do this one. My slope's equal to 2/3. I want a parallel line. So my parallel slope is going to be 2/3 also. This is going to be our x, this is going to be our y. Plug it into y equals mx plus b. We need to find b. We got y, m, and x. We can find b. So this is going to be negative 2 equals 2/3 times 3 plus b. This goes to 1. 2 times 1 is 2. Negative 2 equals 2 plus b. Minus 2 minus 2, negative 4 equals b. So I have my y-intercept. Now, again, we're going to use y equals mx plus b again. Make sure you use your parallel slope. We want a parallel line, use the parallel slope. You want a perpendicular line, use the perpendicular slope. This goes in here. Y equals 2/3 x minus 4. I can come out here and graph this. And we can see I got the same slope. So I go to 4, I go up 2 over 3, up 2 over 3, or I can do negative 2, negative 3. I don't have room to go any further. And I draw that line in there, and those are looking pretty much like parallel lines. This one, only difference is perpendicular. So notice m is, that's really ugly. M equals 2. So m perpendicular equals negative 1/2. Remember, opposite is negative 2, and the reciprocal negative 1 over 2. There's my perpendicular slope. And everything else is just like the previous problem. Number 7. You can look at example 5 in the book. This is honors level. This is optional if you want to try it. I'm running out of time. I'm not going to go over this. You have yourself a good day.